My friends, we're going to solve for the change in the standard molar enthalpy. The delta means change, the H means enthalpy, the M means per mole, and the superscript means it's at standard state at a pressure of 1 bar. When nitrogen is heated from 25 degrees Celsius to 500 degrees Celsius, and we're given an equation for the heat capacity at constant pressure, and this is the molar heat capacity, the standard molar heat capacity, so a pressure of 1 bar, and it's in units of joules per mole Kelvin. Notice we don't have units here, but the equation tells us if we plug in the units of Kelvin for temperature, then the value that we get will be in joules per mole Kelvin for the heat capacity. Okay, so to start this off, we're going to start off with the definition of heat capacity at constant pressure equals the partial derivative of enthalpy with respect to temperature holding pressure constant. We could rearrange this equation to get the infinitesimal change in enthalpy equals the heat capacity times dt. Now I changed a few things here. This Cp and H up here, these are extensive properties. They depend on the amount of substance. So to make them molar quantities, like what we have here, we imagine dividing it all by per m, so we make them all per mole, and we also want them to be in their standard states as well, so we make this superscript right here. Okay, at this point we can integrate both sides from the initial to the final state, and what you may be used to in previous problems is yanking the heat capacity out of the integral by saying that it's constant and doesn't change with temperature. But we have this equation here, and clearly the value of the heat capacity changes if you plug in a different temperature. So it is not constant throughout the temperature range. So we're just going to plug in the equation for the heat capacity into it. And then from here, we have a polynomial. We can integrate this by using the reverse power rule to get the integral of this, and we're going to go from 298 Kelvin to 773 Kelvin. We got to convert everything to Kelvin. Now at this point we're going to plug in the numbers, and it's a little long, but I did it for you here. So this is the first term right here from T final minus T initial. That's the change in T, because we got to go from T initial to T final. So T final minus T initial, T final minus T initial, just like the second term, and then T final minus T initial in this third term here. And if you plug in all those numbers, you will get 13,800 joules per mole, and we usually like to report them in kilojoules per mole, so 13.8 kilojoules per mole. Great. Sweet beans. All right, y'all. Good luck on your midterms. Good luck on your exams, final exams, and all that. I know thermo's not the easiest course, but keep plugging through problems. Keep going, plugging it away. Try the problems that I post on these videos. See if you can do them yourself, and then work through the solutions with me afterwards. And best of luck to you. Thanks for watching this video, and I'll see you in the next one. Cheers.